Hi, my name is Denis, and my topic today is Espressif-IDE for developing ESP-IDF applications. In today's presentation, we will take a look on some general features of Espressif-IDE, and we also will focus more on some important features like memory analysis and debugging features. So Espressif-IDE is IDE based on Eclipse-CDT, which is using for developing IoT application, and it has some plugins like Eclipse CDT, OpenOCD plugin, Embedded CD plugin, and of course IDF, ESP-IDF Eclipse plugin. On this slide, you can see some general features of Espressif-IDE. We'll take a look on them in the demo. Now let's take a look on memory analysis features. So on the left side of this slide, you can see application size analysis editor, which allows us to analyze static memory footprint of your application. And on the right side, you can see the memory trace graph, which is a part of heap tracing. Heap tracing allows us to request heap information, track memory corruption, memory leaks, and this helps us to find some memory-related bugs. Speaking about debugging, Espressif-IDE suggests several options for user, for example, GDB hardware debugging or ESP-IDF OpenOCD debugging, which is more comfortable way to create debugging configuration, because as you will see, we are providing everything for the user, and the user only need to check if his settings are correct and select his board, and he's ready to start debugging. Also, if user is using UART connection, he can put his chip to the panic mode, and with a serial monitor, he can use GDB stub debugging. Also, with using serial monitor and some print functions, he can debug application as well. And the last option mentioned here is application level tracing. Application level tracing is a feature that helps us to analyze program behavior. It's important to say that Espressif-IDE runs on all three platforms, Windows, Mac, and Linux, and it has support for Chinese language as well. Now let me show you mentioned features in a demo. So I will switch to the Espressif-IDE, and the first thing that user needs to do when he opens Espressif-IDE for the first time is to set up ESP-IDF and set up tools. To it, you should go to the Espressif menu and select the first option here, download and configure ESP-IDF. In this wizard, he can use an existing ESP-IDF directory or download the new ESP-IDF by choosing some version, or even clone the master branch to have the latest features of ESP-IDF. As I have already ESP-IDF installed, I will skip this step, and after installing ESP-IDF, Espressif-IDE will suggest you to install the tools, but you can always do it manually by clicking on this install tools command, or by using tools installation wizard, which is now in preview state. Let's take a look on it. On tools installation wizard, we have two pre-configured options on the beginning for Git and Python. On the next page, we can see existing ESP-IDF path, or we can click on new and download the new ESP-IDF, as it was mentioned before, or even clone the master as well. So on the next page, we can see the table with a list of all tools and we can see status for these tools. We can select recommended tools, select all tools, filter it by different chips. We have a type filter here, which allows us to find necessary tool which we can select and unselect. And by clicking install tools, all configuration variables will be configured. And as you can see, my tools are already installed. I will skip this step. And let's take a look what we have here in Espressif menu left. We have this update ESP-IDF master command, which is visible only if you are using ESP-IDF master. So you can easily update your ESP-IDF by clicking on this command. List of installed tools. We can erase flash, change language, URLs to ESP-IDF programming guide and ESP-IDF Eclipse plugin guide, product information, which gather all basic information from the system, which help us to troubleshooting and provide user solutions to his problems based on his product information log. So now when my Espressif-IDE is configured, I can create a new project. To do it, I should go to the file, new Espressif-IDF project. Type some name, click next, and here we can click on checkbox, create a project using one of the templates. We can type text here to find template which we want. For example, I will use app trace to host example to use application level tracing feature. As you can see, I have already created this project in my workspace, so I will skip this step and let's take a look on Project Explorer. I have several projects here which are already built to save some time. So let's go to the Hello World project. And speaking about general features of Espressif-IDE, it's important to mention that we are extending features of Eclipse CDT. For example, code assistant feature. I'm typing ESP, and by combination control and dot, Espressif-IDE suggesting me to finish in my typing by providing me different functions name. Also, as you can see, all my code highlighted in different colors, and I can use a function navigation, which will navigate me to the source code. And also important feature, it's a code formatter. To keep code in same format, we can use a formatter. You can use some existing profiles or create a new one, share it with team members, and you will have all same format for code, which will help you to keep the code in this same template. Now let's take a look on the top side of the Espressif-IDE, where we have different buttons for build, flash, stop debugging. We can select different modes for run or debug. We can select different configurations in this bar, edit it, and same for the target, selecting different target, create a new target, open different terminals. Here we have ESP-IDF serial monitor or ESP-IDF terminal, and we can skip all breakpoints, which may be useful in debug mode. And we have toggle button for DFU. So if we click on it, the build and the flash button will be responsible for building and flashing DFU binaries. Now let me edit the Hello World configuration, and we can see here that we have all pre-configured options, and on the end of this page we can see arguments lines which are generating flash command. If we click flash over GTAG, we will see different command which is for flashing via GTAG. If we select the different target here, for example ESP-32S2, Espressif-IDE will notify me that target changed and will suggest me to delete the build folder. It is because my project is already built, and to avoid conflicts and avoid different problems, it's safer to delete the build folder to rebuild the project with a new target. Let me click no because I'm using ESP rover kit, and you can see that arguments line is changed automatically now to ESP32. I will change it back to rover kit, and the next session we have here is a build settings. So for the build, as a build system, we are using CMake. So in this section we can add additional CMake arguments, provide build command and clean command as well, and we can select different tool chains. As you can see on this list, we have a tool chain specifically for ESP32 target, because ESP32 target is now selected for me. On the next bar, we can provide a different serial port, and we can provide different target, create a different name for it, or even we can delete it if we don't need it. So let's take a look now on the memory analysis feature. And to start memory analysis, we have to build the project first, selecting in Project Explorer, and click on ESP-IDF Application Size Analysis. So we have two sections here. First section provides us general information about static memory footprint in text and in graph formats. It works with the different targets. And the second section is details, which has in-depth details about components and per symbol level memory information. Let's move to the heap tracing features. For it, I will use in sysview tracing heap log project. Let me open it. So for heap tracing, we need to use a debug configuration. I will show you a little bit later how to create a debug configuration step by step. And we also for heap tracing, we have to create at least 2 breakpoints and attach start and stop heap tracing action to them. To do it, you have to right-click on breakpoint, click breakpoint properties, actions, and you will see here create a new action by providing name, type, and name of the dump file. You will be able to create this action. As you can see, I have already created 2 actions for stop and stop heap tracing, and now I should click on attach to attach this action to the corresponding breakpoint. As you can see here, we can see that the action is already attached, and this action is actually start heap tracing. Same for stop tracing. Now let's take a look on it, and we can see that stop heap tracing action is attached to this breakpoint. Also, breakpoints with attached action looks a little bit different from default ones. So you can notice that we have here a tiny icon, which means that some action is attached for this breakpoint. Now, when we select the sysview tracing heap configuration, click on debug, we'll resume from all breakpoints, the heap tracing dump file will be generated. And to save some time, I already did it. As you can see, I have it here. So to analyze heap, I'll right-click on this file and click ESP-IDF heap dump analysis. So we have here three sections. First section shows us heap tracing graph, which shows memory consumption during the time. Also, we can switch to the different context here, update, refresh the graph, and the graph will be updated immediately. And the second section is more interesting. It's details, which shows us different allocation and free memory events and the address where these events happens. If we right-click on some action, we can show colors. Also, we have an interesting option here to view possible memory leaks. So by clicking it, we see allocation events without free memory events. So let's take a look on colors. So as you can see, we have a small table here when we see file name, function name, and line number and address. If we click on it, we will be navigated to the code. As you can see, it's up main, it's the same file and the same number. So very useful feature to track memory related bugs. Now let's take a look on debugging, and we'll start with creating a debug configuration. So to do it, you can click on this bar and create a new launch configuration and select here either GDB hardware debugging or ESP-IDF GDB OpenLCD debugging, which is easier to do it. Clicking on next, and as you can see, all fields are pre-configured for me. And the most important tab here is the debugger tab, because we have here config option for starting the debug session, and we need to check if we have the right board here. So it's correct for me. I have ESP32 router kit, but if you will change it to some different target, it will be generated for different target. Also, GDB executable will be changed for different target. As you can see, it's ESP32S2, but let me change it back to the router kit, and GDB executable is also changed to ESP32. The next step is startup. Here we have important feature which allows us to flash binaries every time when we are entering the debug session, so we'll not forgetting to flash before starting the debug session. And the second option allows us to show more detailed output from OpenLCD. I have already created debug configuration, so I'll click on cancel, and let me start the debug. So we are clicking on this bug icon to start the debugging. It takes a little bit more time if project is not built yet, but project is already built. So here on the bottom side, you can see the status for launching application, and debug is started now, and Espressif-IDE suggested me to switch the perspective to the debug perspective. Let's switch it. And here you can see we have additional options on top, responding for debugging our application. We have attached combination on a keyboard for this action as well. So we have resume, terminate button, step into, step over, and step return, standard debug options. Also on the right side, we can see variable step when you can track in different variables. We have the list of breakpoints. On the bottom side, we can see OpenOCD console and registers. You can move registers to this if you want, and if you step over the debug configuration, you can see that this numbers is changing for the variables. So everything looks as expected. And on the left side, near the Project Explorer tab, we can also see trace for the debug actions. Let me terminate it now. Move back to the C++ perspective. So the next thing is GDB stop. So to be able to use it, I need to switch to the UART connection and switch in it, and need to open SDK config and to select the GDB on panning there. So I need to go to ESP system settings, and here panic handler behavior need to be set on GDB step on panic. It is already set for me, so I will close it. Also, we need to have here cert 0, which helps us to enter GDB step mode. And let me also, we have to select the port. It's already set for me, and flash the project by using UART. So as you can see from the console, project is flashed now, and I can open the serial monitor now. As you can see, we have in Hello World project different printing commands, and you can track them in serial monitor. We can use them to debug our application as well. And now I'm entering to GDB stop now, and Eclipse Espressif-IDE suggested me to change the perspective to debug once more. I'm switching to it, and once again we see all the same thing that we were seeing before: registers, variables, debug trace. But the only difference here is that we can only step here only once. By clicking next, the debug will be stopped. So now let's take a look on application level tracing. I will switch back to the GTEC connection. And I will use app to trace to host project. For application level tracing, we need to right click on the project, click application level tracing, and if you don't have the debug configuration, it will be created for you. And in this configuration, you need to set your target and board as well. I have created it already, so it should start without problem. Yes, in starting OpenOCD, and now I can see application level tracing wizard. Here we have a different field to generate your application level tracing command. So we have output file field for a dump file. Also, we are providing the default log trace procpy script, but it's can be the case when user is using his custom script for application level tracing, so he can select it here, and in the last section he will provide the different arguments, so his custom script will be selected for generating the trace log file. I can't parse it yet because it's not yet generated. To generate it, I need to start application level tracing by clicking on this button. And you can see from the log here that application level tracing is started, and I can stop it in any moment. So when I click on stop, I can click on start parse button now. If I click on it, we will see in the log the result of the parsing of trace log. And we can switch to the different consoles here to take a look what was going on OpenOCD side. So yeah, that's all from from my side for today. And on this page, you can see the link for our IDF Eclipse plugin, where you can create issue, suggest us any idea, or provide us information about bugs which you are facing. We will happy to answer to all your questions, and we will happy to provide features which are necessary for you. So that's all from my side. I hope I managed to reveal all advantages of using Espressif-IDE, and with your help, we will make it even better. Thank you for attention, and that's time for your questions.
Let's add Dennis and Kondal. Hello, guys. Can you hear me?
Hi, everyone.
Hey, hi. Hey, guys.
Perfect. So let's just start with the first question. It's from Netko Dimitrov. Is it possible to use Eclipse with ESP-IDF as well? The ESP-IDF means ESP Audio Development Framework.
Yes, so we should be able to configure the ESP-IDF within the Espressif-IDE. So I think it's already well documented as part of the ESP-IDF, where you could just need to clone the repo. So that comes with the compatible ESP-IDF, and once you clone that, all probably you need to do is you need to set the ADF underscore path within the Espressif-IDE, and then the build should go through. So yeah, it's as simple as that. So you could refer, recently we also documented on this in the FAQs. Probably you could refer to the GitHub page in our IDF Eclipse plugin. So we have clearly documented on the how to configure the ADF in the Espressif-IDE. I think that helps.
Okay, thank you. Next question. ESP-IDE is great, I love it, but sometimes we need some light IDE. There are some solution for Vim or terminal editor.
So yeah, I mean, so we have an Eclipse and the VS Code editors. If somebody is looking for something else, probably the lighter one would be to make use of the probably a CLI. So CLI is having an everything. So you could able to create a project, build and flash, serial monitor, everything you could do. But if someone is looking for OpenOCD kind of debugging features, probably then yeah, they can use Espressif-IDE or the VS Code extension for this.
Okay, next question. Apart from flashing the target, does Espressif-IDE support communication with the chip and getting some info, for instance, reading out fuses summary?
So this is not implemented directly within the Espressif-IDE, but so there is already a Python script from the ESP-IDF. So, but this could be achieved within the Espressif-IDE if you could able to open the, there's something called ESP-IDF terminal from the Eclipse. So this is already pre-configured with all the components like the ESP core dump or eFuse. So you should be able to access those the script file directly from the terminal, and they should be able to run those commands. But yeah, as such, the view is not implemented for the eFuse for verifying that.
Okay, and we have last two questions. One is from Rodrigo Garcia. Is it possible to debug and monitor several FreeRTOS tasks at the same time?
So this is not implemented yet, but Eclipse CDT is having something on this where you should be able to view the tasks and the threads. Probably, you could expect this feature with integration of ESP-IDF in the next couple of months. Yeah, but as of now, it's not there.
Okay, and the last question for you guys. How to run a menu config in the IDE before it first time compiled code and build the SDK config JSON file. Also, how to run summary chip information ESP tool. Thank you.
So currently this SDK config file editor is available only after the build. Probably we'll take this as a the feature request. What we could do is maybe the moment we create a project, we will generate the SDK config file with the default settings, and maybe with ESP that we will try to open the editor. So yeah, that's something we will consider. But as of now, this is not implemented. So SDK config editor is only available after the build with the selected target.
Okay.
Also, one small note to this, that is possible to open ESP-IDF terminal inside of ESP-IDE, and we can run IDF by menu config command there directly and change some options if it's necessary. So it is possible to do even now, but like as workaround.
So thank you for answering the questions live. We have a nice feedback. So it was a nice presentation, Dennis.
Thank you.
Bye-bye, guys.
Yeah, thank you, guys.
Bye.
Now we will go to the Arduino talk.